It, let's get started. Thank you for coming. My name is James Bornefeld Westfall. I work for a company named Neat. We make video conferencing devices. I work as the test automation lead at Neat, testing embedded firmware on our video conferencing devices, which are very innovative. We have the patents to prove that. Um, and today I'm going to be talking to you about a end-to-end test framework called Python Behave, just by raise of hands. How many people are familiar with Behave? Okay, wow, good. What about Robot Framework? Yeah, okay. Yeah, so, so you don't have a sort of a already made up idea about Behave, but Behave is a BDD framework. So behavior-driven development, which is an agile software development process that emphasizes collaboration between business stakeholders, testers, and developers. So basically, perhaps turning upside down and revolutionizing your entire software development process. I'm not going to be talking about that. Even though Behave is a BDD framework, it stands on its own as a really, really good automation framework. And that's what I'm going to try to convince you of today. So nothing negative about this BDD process. I just want to emphasize how much Behave actually is really good as a test automation framework. So I'm going to illustrate several use cases that show how flexible, usable, and yes, modern Python Behave is. This is not meant to be a general introduction to Python Behave, but luckily for you, I'm not assuming any pre-knowledge about Python Behave. Here are the cases I'm going to present for you. We're going to start with GUI automation. So integration between Python Behave and a page object model. A page object model is something you use for GUI automation, and it's basically a proxy for a screen that encapsulates, I'll talk about what it encapsulates, but basically encapsulates page references and operations on a screen in one place, mostly out of the interest of the dry principle. Don't repeat yourself, because if you know anything about GUIs, they will change. So you can't have references to the GUI spread out across your entire test suite and expect to survive. So the page object model is a nice solution to ensure that your GUI automation tests are maintainable. And so it got some other benefits. Then I'm going to talk about avoiding GUI automation because you don't want to do GUI automation. It's basically awful unless the point of your test is to test the GUI. So in other circumstances, you want to avoid it. And I'm going to be able to talk about some C++. I've presented here, I think, 4 times now. This is my 4th time, I guess. And I've never before presented C++ code at a C++ conference. Now, sort of a Rust conference, but yeah. So I'm finally becoming relevant. And after I present that, then we'll be sort of 2025 compliant and talk about machine learning and talk about integration in a Behave test with using a machine learning model for an assert in a test. First things first, this is a great time to be talking about Behave. Behave is very much alive as a framework. It's been sitting in a pre-release state of the next version for a number of years, unfortunately, but now this last August, a new release, the 1.3 release came out. I will be demonstrating something that is new in that release. So it's very, very alive and well. Let's talk about end-to-end testing, and even testing in general. There is a principle that you may not have thought about, and that is your test framework. Your tests have to be much more stable than the software you're testing. Very difficult to achieve, But you see, your tests have to be the rock in the stream of code moving past it if you're going to consistently get value out of your tests. I think particularly when it comes to end-to-end test frameworks, there's a temptation, we'll just roll our own framework. Not a good idea. I don't think so, because I don't think you in your team, however talented you are going to manage to roll as good of a test framework as a dedicated open source test framework. I'm going to present 2 test frameworks today. I don't think you can beat them on your own. I think you have an interest in using a test framework for your end-to-end tests. That's kind of my focus here. But you can use a unit test framework for end-to-end tests. Works fine. I'm all for misusing unit test frameworks, or I sort of feel like unit test frameworks are kind of made also to handle other kinds of tests. But end-to-end test frameworks, at least the 2 I'm going to present today and compare so we can look at them, have one really, really special quality, and that is a unit test framework. So I'm a Python guy, so if you've got a Python module, it's your test underscore something. All of the functions, or almost all the functions in that unit test framework will tend to be proper to just that unit test module. So all the tests in your unit tests, all the test functions, they're not reused. And that makes sense. They're all related to that unit of code or whatever kind of unit the unit test is testing. And that's right. But when you're doing end-to-end tests, the 2 frameworks I'll present and compare, they're based on function reuse. So you can define a bunch of functions for doing things or testing things in your world. So my world is video conference devices. And you can combine these functions to create test scenarios. And I experience when I'm testing my company's video conference solutions that since we've been doing this for 4 years now, when I'm going to write a new test to test some new feature on our video conference device, generally speaking, 80 to 90% of the operations I need to do to navigate around and activate this and listen to that are already defined before in the tests I've already written. That's got 2 big benefits. The one is it makes the tests more reliable. It's kind of like, unit tests, exercising the code a lot. The test code, the test implementation code, gets exercised a lot, so you know it's pretty bulletproof. If there are problems in it, you'll tend to find them. And the other thing is, not negligible, it really speeds up the production of new tests when you only need to test a new feature, write 10 to 20% of the new implementation. So I can really, really recommend, if you're doing end-to-end testing, use an end-to-end test framework. Don't roll your own. So these are the 2 I'm going to compare. Robot Framework, it is the original gangster in the space, and Python Behave. If you're going to make a choice between these 2, well, one of the things you can look at is how much is it used. These are stats from the Python package index, PyPy. This shows basically people's CI runs downloading the 2 different Python packages. So obviously these are not new users of this software every day, but they're comparable. And you can see at this current time, they're basically identical. So, it's if you're gonna look at how popular the framework is, well, use is basically the same. So let me go ahead and actually present these. These frameworks, I need to get the mouse over here. At least Robot Framework has a website that allows you to go in and try out Robot Framework. So we're going to go ahead and do that. And This is a robot framework test. It explains a little bit how it's put together. It's got 3 parts. It's got a test suite.robot, which is kind of a fairly human readable abstraction layer where you can put in these test steps. These test steps are reusable blocks, so you can use the same test steps in different tests. You just include them in this .robot text file. And then you've got this resource thing, which basically says, okay, there's basically 2 things. One thing is you can make composite steps. I'm having a bit of a trouble scrolling down. Oh, please be nice. I'll click here. It's hard doing this. Yes, that's working. So you can make composite steps. So login user is actually putting together several already defined steps to create a new step. So that's very nice, right? Reusing the stuff you have, building up of small, well-tested blocks, saves time, makes things reliable, right? And then also this library is saying, well, yeah, we can also call functions basically in this custom library. And so the custom library, yeah, it's a Python library. And you see, for example, the execute login. If I go back to the first one, you can see we actually are somewhere in here. Oh, I guess it wasn't here, but calling one of these functions that's in the Python file, which here sort of represents maybe the implementation. I can run this, and it will run, and it'll run green, but that's no fun. Let's make the test fail, because that's much more fun. So here we go with robot. One thing that's often seen as an advantage with robot is you have kind of a standard library, so you have test steps that are already defined for you that you can just use. This one is run keyword, because this is like called robots keyword, I don't know, language or whatever it is. So we can run a test step, login user with username and password, and we're expecting an error. So that's nice. This is running using the Python WebAssembly implementation. And so there it goes. There it fails, right? And we get some printout which says expected error did not occur. Right. Okay. So that's robot. It was the original gangster in the space, so got to be glad for robot. Behave came afterwards. Behave is it's an open source project on GitHub. Unfortunately, there isn't on that page something that allows you to try it. But I felt like I had to create that because robot had one. So I have been invited into the GitHub Behave contrib repo. So if you want to try this out, you can. You can also follow along on your phone. So you just need to Google. If you want to try it out, you might want to take a picture or write this down. GitHub Behave contrib try behave will get you to it. Some people taking pictures or writing down. I'll give you time to do that. And so this is also allowing you to try things out in the browser using the WebAssembly compiled version of Python. So here we are, and I sort of explained. So this is not Behave, this GUI, this unfortunate GUI. It's not Behave, it's me. So don't blame Behave for this, but here we go. So here we have a test case that's very inspired by the one I just showed you. That's kind of maybe a coincidence. You see a different syntax. If you look at robot, it really looks like function calls, really. Because it is function calls. Each test step in robot is pointing to either a composite step, like we saw in that .resource file, which is kind of a pseudo function, or to an actual function in some Python code. For example, Behave is also doing function calls, but it doesn't look so blatantly function call-y. It's much more human readable, and that's an advantage of Behave, I think. So in this tool, I have it's always the find my mouse. Yes, thank you. I have made it. I'm showing the implementation of each function one time. This is made possible by the fact that Behave has insanely good metadata that you can use to create an application like this. And I said before, the difference between these end-to-end test frameworks and unit test frameworks, among other things, is that you can bring in functions. So the relationship between a test and its functions is not one-to-one. You can write a test, and it's very normal to bring in functions from a lot of other different modules and reuse them. So I do this here with, for example, I verify I get the invalid password error when I run step. So let's just scroll down until we find that. And, oh, okay. Thank you. That was scary. So here it is here. Interesting things here. So this is a Python behave function. It has a decorator on it that has different decorators given when then, or the generic one, step. I recommend vehemently use the step because my experience is you never know which keyword you want to use this, so leave it open. So just make a step and you can use it with a given, a when, a then, but yeah. The step implementation always takes a context object. That context object is very nice because you can hang things on it that you need for your test. And it also comes with very nice features like execute steps. And this is the way you can make a composite function in Behave. We'll look at a little bit more complicated example of this later. But you can run other steps from within your test step. Here, I'm actually just running the one from context.text. So it's the part that's in the Python quotes there. I log in with user, so it's this one right here, and I'm expecting this to fail. The thing with Behave is that it doesn't have that many or as much standard libraries as Robot does, but this was trivial to implement. So don't make that stop you from using Behave. I will present a standard library from Behave later, but it's very easy to implement your own. So let's run this. And of course, let's make it fail. So I'll just take the password and make it correct. And then I'll do that. Save the file. And I'll run the feature. This is actual Behave. And there we go, right? The test failed. Assert failed. I didn't find invalid password in the error message. So very similar to Behave. Behave and Robot are extremely similar animals. One other thing I just want to mention that is a really good feature about Behave is, and I've worked a lot with Robot, is I think Behave is much more customizable. I've tried with Robot and I've tried with Behave. Pyodide has some weird constraints, so I had to override some things with Behave. The key file for overriding a lot of behavior in Behave is the environment.py feature. Pyodide sort of keeps the module state. And it just keeps getting junked up. It doesn't reset the module state. So I was having a problem with the step registry because Behave loads all the step implementations that are in the path. So that's the easy way. That's how you load your step implementations. They just have to be modules loaded into the Python path. Behave loads them in, and since Pyodide doesn't clean up or it maintains the module state, when I first tried to make this tool, I was getting that step is already duplicated because it was getting loaded again after every time I wrote. So Behave allowed me just to, after all the test is run, to clean up there. And also there was something weird, I don't even remember what it was, with how the formatting was done. So there I could just override the formatter that controls how the log is written out. And that's really nice. Neat. We use that a lot to make sure that our logs are super readable and have everything we need. So it's a really, really extensible, easily extensible framework. So that's the comparison of the two libraries, and I hope you get a feel for how these end-to-end test libraries work. So let's go on. I'll tell you a bit about our stack for end-to-end testing at Neat. So we use, obviously, Python Behave. We're Android-based software, so we use UA Automator 2. We use a wrapper for ADB, Android Debug Protocol. It's a wire protocol. It's kind of like, I worked before with embedded Linux. Then you had to sort of talk to Linux over SSH. Android has a built-in way of talking to the operating system and executing commands called ADB. And we have our own page object model framework. This sort of normal stack, the most common stack when you are testing on Android and also embedded Linux, I've seen, tends to be Robot Framework. Appium, you may not have heard of these tools. It's related to Selenium, a wrapper for ADB, and JSON files with XPath selectors. So basically screen references, screen element references. Here's my 2 cents about this. Robot and Appium. It's crashy. It's hard to debug. Robot is a bit of a strange framework. It was kind of made with the intention of being something for non-programmers. Maybe the programmers would implement these test steps and then the testers would combine them to make tests, and it tries not to scare people who are non-programmers, but it does it in a kind of way that makes it very hard to get information about what is going on in the test, like a stack trace or something. I think stack traces are scary. Behave is more open with stack traces. You can override everything in Behave and control whatever information you show. But Behave is very easy to debug. The UA Automator 2 is incredibly fast. So that's for GUI automation. Much faster than UA Automator 1, just massively quicker. So talking about GUI automation, I'm going to show you the integration between Python Behave and page object model. It's not an off-the-shelf thing. It's our own page object model. Page object model, in a word, encapsulates GUI references, right? You don't want to have references to the GUI spread out all over your tests because, as I've already mentioned, that becomes a very fast and unmaintainable nightmare. So the page object model, which is a set of classes that represent, each class represents each screen, encapsulates the GUI references. That class, it's almost like a voodoo doll. It's what you do to the class happens to the screen, right? Also encapsulates operations, so log in, log out, connect to Wi-Fi, whatever kind of operations. And I put in a unicorn, navigation. There's not that many people who encapsulate navigation in page object models, but I really recommend it because if there's one thing that changes a lot in applications, it's also navigation paths, navigation hierarchies, how you go from one screen to another. So if you have that spread out all over your tests, you're going to hit a maintenance problem. I've seen people with navigation in a page object model, but I'll show you something I haven't seen before. So this is our class. It's inheriting for page base, which has lots of nice stuff. We've got the references. I've got the references here as a Python named tuple. One way I've seen references handled was would just have individual class members with each selector, but I wanted to have that as one class member amongst other things so that I could loop through all of the classes and make sure that the selectors were unique, that I didn't have the same selector defined several places. I also have a file, actually, sort of a special class with the shared selectors, which is taken into account by the linter that I've written to ensure that every GUI reference is just defined in one place. So if, and of course, when that GUI reference changes, I just need to fix it one place and it's fixed everywhere. Name tuple is a way of bringing type safety into Python. It's really cool. You see I have an operation here. kind of a couple operations. The get meeting ID, it's kind of an internal operation that helps other tests. You see I'm hanging the meeting ID on this context object that comes in as the argument to every test step. There I'm using actually I'm not using it there. Sorry, it's in the exit, and then you see the self refs done icon. If I misspelled that icon in VS Code, I get red squiggly marks. I think maybe other IDEs will pick that up. Also, we have linters. Our linter picks it up. So you end up having a collection with members that work sort of as if they were strongly typed. Basically, if you misspell them, things start screaming at you. That's really good. This class has an on method. That on method is used to assert that you're actually on that class. That's also using one of these selectors there. That's the other selector there. We'll look at how the on method is used in a test very quickly. And then we have two. Here we can just navigate from this screen or from this page object model that represents the screen to another destination, which is a Zoom meeting. And it actually returns if you see the two, it's it sets the next class reference right here. So the to method, the navigation method, gives you the reference to the next page object model. And that allows me to do something like this, which is really beautiful. And this is something that Behave makes possible, because you saw previously when I was demonstrating code in Behave, maybe that you had some double quotes around the arguments. Those are not required by Behave. You can make this completely fluent. You can start getting it so it doesn't look like these are function calls. So our model says, given the current screen is Teams logged in, that will make the framework pull up the Teams logged in class, call the on method. The test will fail if you're not there. So it's kind of declarative. I say I'm here. It will check, it'll call the on method. Are you actually here? I'll check the reference, the thing I'm expecting on the page that means I'm there. And then I take the shortest path, right? Computer Science 101, how do you find the shortest path in a directed acyclical graph? So that's really nice. Then I don't have to junk up my test code by spelling out the navigation paths. They're just implicit. And if it changes, this will just work it out, and I don't need to modify this test or the 10 other tests that are doing navigation. When I sign out of Teams, so that's an operation, and then that takes a while for the app to stabilize, and then a new assert, the current screen is Teams welcome. So then we'll call the on method in the next, in the screen that we ended up navigating to implicitly by logging out. So the page object references, they just glide in. And also, like you see here, I'm waiting for 40 seconds. Teams is, anybody use Teams? What can you say? Teams is Teams. So we're starting to look like very human readable stuff that is function calls in the background, but doesn't really look like it. So it's really, really nice. Just talking about web automation. So we need to automate some web screens, web sites, I guess. Sometimes, for example, if we're testing with one of our video conference devices that is in a conference with Teams or a Zoom web page with a web client. So there we use Python Behave. There we use Playwright, and then we use our own POM framework. Let's look how this looks. It looks really, really similar. So the model works really nicely. You can see the references are a little bit different. It's self-page, and then you have these get by. So Playwright is sort of made to work with page object models. It has this page reference. but it just passes right in with the model. We can also do duplication checks with the linter with this, and we do. Yeah, and in the different, so we have the on, and we have operations, and we have navigation, a couple navigation choices, and yeah. So it works very, very similar, and it passes right in. Here's what it looks like on the web. Right, exceedingly similar. You say, yeah, this is the page I'm on, and then you can navigate. No shortest path here, because usually the web doesn't have such deep hierarchies. And yeah, so works really well with Behave, just glides right in. Just quickly on switching from Selenium to Playwright. Blazingly fast, very reliable, and also the tooling for generating Playwright and finding the best selectors is it's my first experience with generated code being usable. So yeah, just on the side. Let's shift focus now. You don't want to do GUI automation. You really don't. Sometimes you have to, because like my company's named Neat, and we want our software to be neat, so we have to ensure that the GUI behaves. But we'd avoid it if we could, and so that's what I'm going to talk about. We had an interesting opportunity. The folks at Zoom came with a C++ API that would allow us to instrument the Zoom app on our video conference devices without doing GUI automation. I said, yes, this is so good. And so basically we could do things like just say, poof, be in a meeting, or poof, mute the audio without doing GUI automation. And that's really good because we test a lot of things that aren't the GUI. So if we're in a meeting, for example, we test the video and the audio streams. And we also test the machine learning algorithm that is doing the auto-framing and putting all the participants in the room in their own box so that the remote participant can see everybody clearly and actually feel like they're being a part of the meeting and catching everything that's important. That's one of the patents we have, by the way. But the API had a kind of an odd requirement. It was a very low-level API, and Zoom said, yeah, there's this method here on the API, which is, yeah, heartbeat. You have to call it every 150 milliseconds. So with everything else you're doing, you just have to make sure your heartbeat, do stuff heartbeat. I'm not a good C++ programmer. I thought this was a nightmare. I thought, why is it this way? But I am a Python guy. And suddenly I got this sort of sneaky idea. Ooh, well, this sounds like a case for async I/O. So one of the newer functionalities in Python, you have to declare your function as async, but I could just start this little background thing just banging away and then go about my business. I had to create a wrapper from for the C++ because Python speaks C natively, but it doesn't speak C++ natively. So I just used Boost. So this is Boost. And I exposed 3 methods to C. So the one was init. Okay, yeah, I got to set some stuff up. Pulse heartbeat, so bang away at that heartbeat, and then send command, and I can send different commands, and we'll look at which commands. So let's look at the Python behave code. This is async. You remember I mentioned that Python came out with this new Python behave came out with this 1.3 version. It's now 1.3.3. That came with support for async functions. You just have to put a decorator on your Python behave function, run until complete. There's also a nice thing here, just showing off Python behave. You can use multiple step texts to refer to your function. And you can have defaults. You can just say, for example, if you're not sending in a code, just set it to none and handle it in your code. So super, super flexible. Beautiful. Yeah. And so async works. So what am I doing? Well, I've basically got my function up here that's just going to live its little life, banging away at that heartbeat there. Needs to be an async function. It's like async creep, right? Async functions have to call async functions. So yeah. But Python behave supports async functions. So I was able to program my way out of this little problem without doing much in C++. I import my library. It's compiled somewhere. That's not so pretty, but whatever. And then I start the task, and after that, I pair the device with the API via the code that gets shoot in, and then finally down here, I start a meeting. So no GUI automation. So that's really, 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 really cool. And I'm very glad that Python Behave, the latest release version, supports that, because yeah, now I can just say, poof, let there be a meeting, poof, let there be sound, poof, let you be muted. And it's wonderful, because I don't like doing GUI automation if I don't have to. So that's the second case. Let's look at the third case. And this is the integration between Python Behave and a machine learning model with a command line interface. So it's 2025. We should be using some machine learning stuff. And so we had an interesting problem. The Zoom app, basically, if you switch the language to Turkish, it crashed. So I thought, okay, let's write some tests for this. And it really seemed like a case for using an LLM, generative AI. It didn't work out so well. Well, because generative AI my experience tends to be often very disappointing for any task other than code generation. But it also jumps to conclusions really fast. So what happened? I will switch the language, and then it will be in German. And the tokens start being processed by the LLM, and they're saying, Willkommen bei, Zoom, okay, rooms. That's a mixture of German and English. Uh-oh. Anmelden, okay, that's German. Test meeting, that's English. What happened? What do you think the LLM said when I asked, what language is this? English! Or at least half the times English, maybe a third of the time English. But, we're testing 10 different languages, so this was a nightmare. It just didn't work. I've been using scikit-learn a lot, looking at classifying test failures, for example. But this was another case where I thought, ooh, okay, we can use scikit-learn. So I made a little model, and it's actually just exposed by one script file. The first thing is to train up. So I read some CSV files with a bunch of basically the same articles in different languages from Wikipedia. And scikit-learn has this really nice pipeline construct. Recommend it wholeheartedly, because you can algorithm shop. You can change which algorithm. Multinomial Bayes turned out to be the right one. We'll talk a little bit later by why, but there's other things that can work. This is basically just looking at word counts using the TF-IDF word counts. So you're basically looking at the frequency of terms or the infrequency of terms and using that to identify documents as, in this case, being German or Russian or whatever it is. And always good to cross-check. So we're checking the accuracy. On the sample set, it's like 90-something%, so it looks pretty good. And then we have predict, and this is if we send in a text file, basically some language, then we'll call the predict, and it will read the words and try to figure out which language it is. I mentioned that Python Behave maybe doesn't have so many standard libraries as robot, but it actually does have one behave for command. So this is you can just install behave from command from GitHub. You can add GitHub references to your requirements.txt in Python. And so that's how I solved this. Don't take this as Python behave has to work with command line scripts. This is right. You can just import Python behave as Python, so you can just import functions. But this turned out to be a sort of an half elegant way of solving it, because I could have the same script for training the model as I could for invoking the model. This is using Python behave for command. So basically I'm sending in the language. It's got to be one of these. I'm grabbing the screen text, and then I'm using context to execute steps. And I mentioned this is the way behave does composite steps, so steps which are made up of other steps. And so then it can be really pretty, right? I can actually just define, so this is behave for command, that standard library step, given a file named screen text with the screen content, which I'm shooting in. When I run my Python script that's executing my machine learning model, then the command output should contain the languages. So it's looking at the what's printed out by the script. And yeah, okay, it's a choice, right? Just having one script for both training the model and invoking the model. Why not? And this works beautifully. There's never been a false positive with this test. It's been running for about a year or something. The LLM failed miserably, whereas this has worked perfectly. So kind of my wish for you is that your test code will be that rock in the stream of code flowing past it. So I think the point here, which I'd like to make and start wrapping off this talk with, is use the right tool for the right purpose. And I really, really hope I have convinced you that for writing end-to-end tests, even if you're not doing BDD, software development process, that behave is a super, super good choice. I'll round off a little bit and summarize the things that I've presented. So that natural language support and behave makes it really easy to work in a page object model and have a modern way of testing GUIs that just flows, and that these tests are very readable doesn't hurt, even if you're not doing BDD. It's really nice that you have human readable tests. Second thing is, yes, in my case, I'm not such a good C++ programmer, so Behave 1.3's support for async saved me and allowed me to integrate with that C++ API. And I think basically CPython is a very cool thing that is very interesting for tests, that we have an easy way of going and talking to C. And I hope I've illustrated at the C++ conference that it's not very difficult to make a wrapper to talk to C++. And last thing, yes, the behave for command library makes it really easy to work with different command line tools, which when you're in testing embedded software, that's a big plus. So yes, thank you very much. This somehow went really, really quick, so we have plenty of time for questions. If you are shy and you don't want to ask a question, then you can just contact me at that email. Any questions? Yes?
So one of the advantages with these frameworks is that you can easily read the tests
Yes.
as a human and see what it's actually testing.
Mm.
But have you gotten to the point where non-programmers has actually have implemented the test? Can you get non-technical people to write the test, or is it still the Python programmers that are writing it?
Yeah. I mean, I had some experience at a previous employer where non-programmers were able to put together test steps to create new tests. I think really kind of the ideal use case for using Behave is in cross-functional teams where you have perhaps testers who aren't maybe strong programmers or aren't programmers working together with developers, and the testers are talking to the developers about what kind of test steps they think they need, and then there's a good back and forth dialogue, because I think also sometimes the programmers need to push back too and say, well, have you considered doing this way? So I think Behave is an ideal tool for cross-functional teams.
And the second question is, do you have a separate system where you maintain your requirements, or do you say that the tests are the requirements?
Jira.
Jira is the requirement base.
Yeah. But we also, to be honest, actually also we have X-ray. But X-ray is just what we use to ensure that we ran every test that we thought we were supposed to run every night. But generally speaking, I mean, I think, yeah.
So if external people are trying to read through the requirements, they go to Jira?
Yeah. Yes?
Question about the test steps. Kind of, how do you organize test steps, and how do you kind of design your test steps? Or do you just, can it get messy, or?
Yes and yes and yes. Yes, it can get messy, but the really nice thing about Python Behave is that it's really easy to refactor. Right? The only requirement for a test step is that it has the Behave decorator on the function, right, with step text. And if you realize, oh, this was in the wrong place, you just move it. That's fine, just as long as that module is loaded into the Python path, then you never notice it. So that works really well. I sort of like to have the test step implementations that are specific to a specific functionality in a module that has the name of that specific functionality, and the ones that are for general use in sort of themed modules for whatever type of general use it is. So I think test architecture and thinking about this to make it easy for people to find and reuse the test steps is something that merits a lot of thought. And the other thing that's really nice is the fact you can put overrides, different step texts, because you might want to use an existing test step, but a little bit differently. Maybe you want an extra argument, and so then you can just make that argument optional, default to none, or some sane default value, and then add the functionality around that extra argument. So that's also really nice and makes it possible to sort of avoid duplicating steps and adapting them as you go on. Is that a good answer? Okay. Did I answer, or more of the question was, did I answer your question fully?
If you have many test steps, it can be hard to find them, and you answered kind of how you can arrange them. And also that you need the test step, you want test steps to be reusable, and you have some measures for that too.
I had a talk last year which was test architecture is a real thing. So if you're interested, look at that. I mean, I think architecture is basically that thing that you run into often too late when you start scaling up to, for example, a lot of tests, right? If you don't have a good architecture, when you don't have too many tests, then you're going to crash into a wall. So these things are very worth thinking carefully about, because it's easy to maintain 5 end-to-end tests. It's a big challenge to maintain 500 or 1,000 or more end-to-end tests.
I think I attended to that one last year.
Yeah. Other questions? Yeah.
Is there some framework way to, like, if I want to have a test
Yeah, Python Behave uses a, I forgot the name, Cucumber tags library. So it uses an external library, which makes it possible to define which features you're going to run, and even selectively which scenarios if you have tags in the scenarios. So yes. Yeah. So look at Cucumber tags. And Python Behave is interesting because it's moving in a space where like the Gherkin language is actually a standard, and it's pulling in these things like Cucumber tags, which is an external library and also kind of a standard. So yeah. Was there a question here first or no? You're scratching your head. Yes. Version control, we use Git. Yeah, well, I mean, we use merge requests. We're using GitLab. I'm sorry? It can definitely follow a project. We sort of have a mono repo. So, yeah. We're sort of into a mono repo approach. Sometimes when we know there are big changes that are coming, we'll kind of branch out a branch to keep compatibility with the like a release branch. We generally focus our test effort on main because I have this very, very strong philosophy that, keep improving the shit until it turns into gold. A lot of testers think you can't test against main. What does that mean? It means you're merging out release branches, making those release branches beautiful and nice. They go out to the customer, and then you're throwing away all that work. So focus your effort on making main good. Yes, it's chaos, maybe, because people are checking in stuff. Look at my talks in previous years. I talked a lot about following test trends instead of individual failures as a strategy for dealing with that. So I believe strongly at let's test the bleeding edge and make the bleeding edge less bloody. I don't know, was that an answer to your question? You're okay. Okay, I'm okay. Yes?
Speaking of frameworks, you have PyTest, which is a unit test framework.
Yeah, I love PyTest.
Which is also pretty extensible. You can make your own plugins and features and stuff like that.
Mm-hmm.
Have you been through a phase where you were using PyTest and then you went away from it?
I actually had the interesting experience where I was working with Behave at a different company, and then became an employee at Neat and took it with me, and was basically the person who was responsible for starting the test automation effort, and then got a bunch of colleagues afterwards where it was too late for them to choose anything else. So, but PyTest is nice. PyTest has a BDD module, so you can write things in Gherkin. The thing I don't like about that is that the test steps that you use in them, they're just like normal unit tests. There's nothing built in for sharing the test steps and reusing them. So it's basically just allows you to write a unit test with given, when, then syntax, a bit like Catch 2, which I love Catch 2. Catch 2 is a cool framework, so I support it. But I would suggest it's not a substitute for an end-to-end test framework if you're doing end-to-end testing. Yes, other questions? Somehow I had. Thank you.